Up, geometry students, let's do the Unit 5 review. I'll try to get through this quickly because there's a lot, but very good. Last thing we learned from the unit was about portions or like percentages of circles. And if we want to make any adjustments, area of a full circle is pi r squared. But we want like the portion or the percent of the circle. So we want to like do the kind of like a part out of our whole. So in this case, we'll have like our angle measurement out of 360. And their circumference, 2r pi, 2 pi r, whatever you want, like 2r pi. I don't know why we don't do 2r pi. And then part over whole. So the length of this arc, where this angle is 20 degrees, would be 2 times r times pi times the percentage of my circle. Listen, if you don't have a calculator, I will allow you to leave this answer. You probably should divide by 10, divide by 2, and it's 4 pi times 1 over 18. Then that's 4 pi over 18. Divide, divide by 2 is 2 pi over 9. I want that answer. If you're using a calculator, we don't like to incorporate pi. We like to figure out how many amounts of pi. If you're using your calculator, I probably would just do the 2 times the 2 times the 20 divided by the 360. And I would turn that into a fraction. Math, enter, enter, and you get that 2/9 pi. Area would be the pi r squared, and then the portion of your circle. Again, why isn't it r squared pi? I don't know. So this is 1/18 times 4. It actually is 2/9 pi as well, though we don't like using 2 for a radius because 2 times 2 is 4 and 2 squared is 4. So let's just change this to 3. If this was 3, it would be 6 pi times 1 over 18 and 9 pi times 1 over 18. The diameter is 16, the radius is 8. We have pi r squared, so r squared pi times 1/8 of the pizza. Okay, cool. We got two circles. The bigger circle, the radius is r plus 5. The smaller circle's r. So we have r squared pi, and then we have r squared, r plus 5 squared pi, and then we have r squared pi. And we want to subtract the two. I got to figure out what r plus 5 squared pi is. It's not r squared plus 25. It's a common mistake. It's r squared plus 10r plus 25 pi minus r squared pi. Now, if we distribute the pi, we realize we have r squared pi, 10r pi, and 25 pi is the bigger circle. Subtract an r squared pi. It's a very good question involving algebra. But I screwed up. We want circumferences. My bad. I wish it said areas. So 2r pi minus 2r pi. That's 2r plus 10 pi minus 2r pi. That's 2r pi plus 10 pi minus 2r pi. 10 pi is the difference. It's pretty cool. I'm sure there's a non-algebraic way to figure that out, but this is a really good question. And we did it with the areas before. Okay, we got two semicircles and we got a rectangle. The perimeter of the figure is 20 plus 8 pi. All right, cool. Well, we got this, we got that. We got two semicircles that have a radius of that. Combine the two semicircles and you get a full circle. Okay, so it's important to kind of figure out where these numbers come from. Like the 20 has to come from these two lengths here because the circumference of a circle typically involves amounts of pies. It doesn't have to though. Like, I bet I can figure out two different answers to this question, but I'll go with the easier route. Let's assume x is 10, and then if like 2r pi is equal to 8 pi, that means r has to equal 4. Okay? Or y has to equal 4. Therefore, the area would be, this would be 4 as well. 4 plus 4 is 8, so 10 times 8. And then we have a full circle, which is a pi r squared pi. So I had to get 80 plus 16 pi. Now, what if I decided to do this a different way? Could I do this a different way? Yeah, like, I don't want to confuse you, but what if I said that 8 pi was this? So this x is 4 pi. And what if I said 20 was the full circumference of the circle? So 2r pi equals 20. So r is 20 over 2 pi. Let's see if I'd get the same answer. No, I wouldn't. Because this would be 20 over 2 pi, and this would be 20 over 2 pi. Then it would be 20 over 2 pi's, or 40 over 2 pi, or 20 over 2 pi again. This is 10 over pi. So we'd have the area is 4 pi squared. And the area of the rectangle is 4 pi squared. The area of the circle is pi. Oh no, the area of the rectangle is 4 pi times this plus this, which is 20 over pi. What is it going to give me? Wow, it's going to give me the same answer. Plus pi times r squared. I get 80 plus, oh, now it's close. Close. I do get 80, but then I get 100 over pi, which is not the same. Anyways, easier way is probably good. Some of the interior angles, we have a bunch of triangles. How many triangles do we have? Two less than the amount of sides. So the exterior angles, they always add up to equal 360. One interior angle of a regular 26 gon. Well, I'd have 24 triangles. So 24 180s and divided by 26 would give me my answer. If you want, if you don't feel comfortable with this, then you can do it. 166.153. This is good. So hexagon, 1, 2, 3, 4, 5, 6. Hexagon is the bestagon because it's made up of equilateral triangles, which means that's 60 and that's 60, which means CBA is 120. The interior angles are supplementary to the central angles. So if this is 60, this is 120. And you could also say this is a 60 plus a 60. If you didn't know that it was all 60-degree angles, you could have done 360 divided by 6 to get that. Or you could have done 180 times the 6 minus 2 sides divided by 6 to get 120. DEO is going to be 60 degrees. EFM is going to be 60 degrees. The exterior angles are the same as the central angles if it's a regular polygon. Okay, the way I like to do this problem is different. I'll call this the easy way, easy way, which is if the interior angle is this, the exterior angle has to be the complementary 180 minus this, so 22.5. Cool. Well, the sides times the angle, the exterior angle has to equal 360. Which means 360 divided by the angle will equal the number of sides. That's the easy way to do it. "16 sides." Or probably the harder, that's not much harder, is that you take 180 times n minus 2, the sides minus 2, and divide it by the total amount of sides. You should get that interior angle 157.5. Multiply both sides by n, distribute this, subtract, you end up with 22.5 n equals 360. It's the same as this, just a harder way to get it. Multiplied everything by n. I then distributed the 180, and then I subtracted 157.5 n's. Then added the 360, added the 360, and then I divided by 22.5. I think this is easier, is that the sum of the exterior is 360, and that means the amount of sides times each exterior angle is 360. Okay, 1, 2, 3, 4, 5. It's a pentagon, which means it's got 3 180s, which means this is going to be the sum of the interior. And 3 180s is 540. Oh, that means the sum of all my angles has to equal. So I'll just subtract. $120. Cool. Well, it's the area. All right, this one we're giving the height. All right. Now, what's great about this is that it is a hexagon. Hexagons are the best hexagons because it's a hexagon. All of these angles, the interior angles are 60 degrees. So this angle here is 60. How did I do it? I did 360 divided by 6, which means if I split that in half, that angle up top is 30, which means I have a 30, 60, 90 triangle. Yeah. I'll show you how to do it using the special right triangle, and then I'll show you how to do it using trigonometry. So I know these side lengths of a 30, 60, 90 are 1 root 3 and 2. That means I have to scale this by doing 14 divided by root 3. All right, so that means this base length is 14 divided by root 3, and this is 28 divided by root 3. Cool. We want 6 of these triangles. These triangles area is 1/2 of the base times the height. Well, this is half of my base. So this is half of my base times my height, and I need 6 of them. This gives us our answer in a calculator ready form, which I like. If you want to use your calculator, you do 14 times 14 times 6 divided by root 3. I would like you to have that as your answer. So I got 678.963, and I'd like you to do it this way if you're my student. But if you did not notice that it's 30, 60, 90 triangles, well, you would have to use trigonometry to find this base length. You know that this is 30 degrees or this is 60 degrees. This is 14 inches. If you were my student, you probably would have done that this is the sine of 60, this is the cosine of 60, and this is 1, which means you would have scaled this by doing 14 divided by the cosine of 60, which means this length here would be 14 over cos 60 times sine of 60. That's the same as this, and then you would have had half of your base times your height times 6. If you are another student and you don't like to scale your sine 60 cosine 61 triangle, you're probably using trigonometry to find x, and you're saying that the tangent of 60 degrees is x over 14. It's not 14 degrees, it's 14 inches. And you're probably then saying that this length here is 14 tan 60. Type in 14 over cos 60 times sine 60, you get this. Type in 14 tan 60, you get this. Or use your special right triangle, get 14 over root 3, you get that. Okay. Okay, cool. I have to double check this. I feel like I did something. Oh my gosh, it's 30. Oh my gosh, it's 30. Wasn't thinking. I bet. Teachers make mistakes too. There we go. And then if I do 14 sine 30 over cosine 30, I would get that. Oof. Make sure you have the correct angles. My bad. My students would have scaled um, this, where they said this is the sine of 30, this is the cosine of 30, and this is 1. 14 over the cosine of 30 is the scale factor. Other students would have set up the tangent of 30 is to the ratio in any 30-degree triangle of opposite over adjacent is equal to this. The ratio in our triangle is this. Solve. Oh, this is fun. I feel like we haven't done that. I'm going to assume this is the center. If I do 180 divided by 3, that's 60 divided by, if I do 360 divided by 30. This is going to be 60. So 360 divided by 3 is 120. So that means this angle here is 120 degrees. Split that in half, and these angles are 60. This is great because we have another 30, 60, 90 triangle, only it's a 1 root 3, 2 in this orientation because this is the 6-degree angle. Which means the scale factor is actually 3, which means this base length is 3 root 3. So I would do it this way, and I would have half of my base times my height, 3 of them. Half of my base times the height, 3 of them. So I got 27 root 3s. If you were to use trigonometry, you would say this is the sine of 60, this is the cos of 60, and this is 1. You'd say the scale factor is 3 over the cosine 60, and then you would multiply that by the sine of 60. If you use trigonometry, you'd say the tangent of 60 equals x over 3, 3 tangent 60. So this 3 root 3 could be written as 3 over the cosine of 60 times the sine of 60, or it could be written as 3 tangent of 60. But team, if we ever have a 30, 60, 90 triangle, we want you to use the special right triangle side lengths. Cool. 60 divided by 5 gives me one of the angles. Divide that by 2 gives me half the angle. So this angle is 72 degrees. And if this is 72 degrees, this is 36 degrees. Great. My students are going to be saying this is the sine of 36, this is the cosine of 36, and this is 1. The scale factor is 5. If you did it any other way, it doesn't matter. You get the sine 5 sine 36 and 5 cos 36. Cool. I have half of my base times my height. Five of them. I don't like how we have the same repeated numbers. Like I would not give you a radius of 5 if I have 5 sides. This is the number. This is the radius twice. Cool. The perimeter would be 2 of these 5 sine 36s, or 10 sine 36. This is double. The perimeter is double my 5 sine 36 5 times. Many of you probably want the answer because you'll feel comfortable. It's 59.441. Here, 1050 sine 36. 29.389. All right, cool. This is a semicircle. The radius is 6. Area. I'll have a 12 times an 8 here, and I'll have a r squared pi half. Add those together. Good. 12 times 8 is 96. And then plus 18 pi. Plug that into your calculator if you need to, but you're better than that. This is 100 for the entire square, but then I have to subtract this pi r squared pi half. So this is 25 pi over 2 because it's half of a circle. And it's a square, so that means this is 5 here, which is important. So I'm going to say minus 25 pi over 2. I have a quarter, and then I have a quarter of a circle, and then I have this triangle. I'm going to find the quarter of the circle and subtract the triangle. So I have pi r squared quartered minus base times height divided by 2. Great. Ooh. Regular pentagon with a circle removed. So let's find the area of the pentagon minus the area of the semicircle. We just did a pentagon. 360 divided by 5 divided by 2, or 180 divided by 5, is 36. So we know that one of our triangles has a angle measurement of 36. We've done it enough that we know that this is 6 sine 36 and this is 6 cos 36. Whether you're scaling or you're using your ratios, you're good. That means this radius is 6 sine 36. So the area of a pentagon is my half of my base times my height 6 times, and then my radius squared times pi divided by 2 is a circle. Half of my base times my height 5 times. Finally, we have a number that's different. Like that's what we wanted in the beginning. We don't like the numbers that are seen. Okay. You want that answer? I'll give it to you. Stuff to do it. 6 sine 36 times 6 cos 36. 5 times the area of the pentagon. R squared. Use parentheses. Or do it one step at a time. Times pi divided by 2. That. Subtract the two numbers. Pop, 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 up. Enter. Minus up. Enter. I actually like this answer. If you left this answer on your test, for me, I'd be okay. Cool. Hexagons are the bestagons. All right, there you go. 6 foot side length. The garden will be a circle that extends 10 feet from the vertices of the hexagon. What's the area of the garden? Garden is this. This is a great. I love this question. It's a great question. Whoever came up with this question. All we have this is a 6. We do have this as a hexagon. Thank you, hexagons. You're the bestagon. Because hexagons are created with a bunch of equilateral triangles, and equilateral triangles split in half are 30, 60, 90 triangles. 60 degrees, 30 degrees, 90. Small, medium, side length ratios must be the same. That is split in half so that this is just 3. If this is 3, the scale factor is 3, which means this has to be 6. Of course it is. Because they're equilateral triangles, the side length is the same as the radius length, which is nice. But this is 3 root 3 here, which we need. Cool. That means the radius of my circle, that's what I have to do. I have to do the area of my circle and then subtract the area for your pentagon, hexagon. Now we have the radius is 16. So we have 16 squared pi is the area of the circle. What is the area of the hexagon? Well, we have half of my base times my height 6 times. Half of my base times my height 6 times. And that's the answer. If you want it. You got it. $710.716. Oh, last page. Area is 338. Its height is twice the length of its base. So if this is x, it's 2x. 2x squared is 338. Divide by 2, square root. $13. I also like it when we're adding and then you have to distribute. So see if you can be ready for that. So I like it when we start with a square and then add 7 or something, and that area is some new number, and you had to do x plus 2 times x plus 7 equals the number. So r squared pi is the area of the circle. Ooh. Okay, if we have 360 divided into 4, each of these are 90, which means each of these are 45, 45, 90. Special right triangles. If you have the hypotenuse, you divide by root 2 to get the length. So this is 1 over root 2 times r over root 2. And this is r over root 2. So we have 2r over root 2's squared, which is 2r times 2r, which is 4r squared. Root 2 times root 2 is root 4, which is 2, which means you get 2r squared. Is that right? Wow, that's cool. R squared pi minus 2r squared. It's good. Perimeter. X. It's an isosceles, so that's x. This must be x root 2. Since it's an isosceles right triangle, it's a 45, 45, 90. So if you have your side lengths multiplied by root 2. So the perimeter is 1, 2, 3, 4 of my x's plus an x root 2. I'm not including that in the perimeter. So I have 4 x's plus an x root 2, or root 2x. If x was 10. That's the perimeter when x is 10. area. I have x squared, then I have 1/2 base times height. So this would be 1/2 x times x. So I'd have x squared plus 1/2 of that x squared, which is actually 3/4 of an x squared. No, 3/2 of x squared. I have 1.5 x squareds. That's the way to think about it. I have 1.5 x squareds. 1x squared, 1/2 of an x squared. What is the area equal to 96? And divide by 3, then multiply by 2. Divide by 3, I get 32. 64. 8. Fun! I really like those problems. Good stuff for your test. All right. Come in with questions or for extra problems. Peace.